Hello and Assalamu alaikum. My name is Fakisha, and in this video, I will be discussing some assembly programs in Atmos Studio and in Proteus, and then we will also simulating those programs in the Proteus software. So here I have a first program in which I am loading this hexagon number in R16 register, and then I am outputting it from port D. And secondly, I'm taking loading our this hex number in R17, the register 17, and then I'm adding both the hex numbers from the registers and outputting from port D. So if I if I show you this circuit diagram, so here I have using all the port D outputs for the output of hex number. If I start the simulation, you will see the addition result that has occurred. So this is our simulation is running. So here you can see the output of addition of our register R16 and R17, which we are taking the output from port D and the form of LEDs. This is the output in hexagon numbers. There are 8 numbers, 8 bits we are using the output. So this is the result of our first program. So here we have our second program. That is, we are loading 00 and R16 that we are using as input. Port is our input register is our R16, and we are using it to make DDR-B, that is B port, as input port. And then we are loading R16 with this value, that is 11, that is 3, and then we are outputting that with on DDR-D, that is our D port, and then we are taking input from R16 from register R16, that is pin B, and then we are taking output from port D, that is R16. So if I run this simulation, this is our circuit of Proteus. If I run this, I've given 1 over here and 1 over here. So here you can see that if I'm giving this first bit as input, so I'm getting this first output, and I'm giving the fourth input, and I'm getting fourth output. So if I change that twice, my inputs, I will get respectively output from here, these ports. So if I move on to our next program. So over here, I have a program for battery charging indication. So this is, I'm loading R16 with FF, that is all bits on, and I will be making as output device. This is port is what is being used as output port. So R16 I'm loading in it. So over here I'm in SPI command, that is I'm only using this 7-bit first. And getting output from 7th bit of 7th port of this D port. So then I'm calling delay functions for some time delay, and then I'm switch on this getting output from the 6th port, then I'm using 5th port and 4th one, 3rd one, similarly to 0. So I'm using to all this port one by one with a delay, and this is my delay function where I'm using R20, which I'm showing with 24, R21 with 25. I'm calling this number again just to create a time delay. So if I show my circuit over here, so this is circuitry. I am getting output from over here, output D port, and if I run this simulation, like this indication are getting filled with time to time. If I run this again, so they increase in an order, ascending order, one by one to the end. If I run this again, So this is first, second, third, fourth, fifth, sixth, seven, eight. So all these are indicating the levels, fulfilling one by one. So now we move to our next program. So here in this program, I'm loading R17 as an input, as 00 is an input, and we are using D port for the input. And similarly, R18 is loaded with 0. Similarly, we are using D port as an input port, and R19 is loaded with all bits high, which means we are using it for a output source. So this C port we are using for the output. So R19 is being stored in it. So we are starting with the here from we are taking input from from pin B in R17 and pin D in R18, and then we are complementing this R17 and R18, and then we are calling the next function, that is if this will move to this over here, that is R17 is this 00110011, and then we are moving on port port C, sorry, as output from R17, and then we are jumping over here, that is loading R17 with this complemented bit, and then we are getting a port C as an output. So if I show you a circuit over here, we are using port C as output and port B and port D's first 4 bits as an input. So if I run my simulation, you will see, if I run the simulation, okay, so this is our complemented output, that is 001100. So moving to our last program. So over here in our last program, we have used some different commands, which we will be seeing from our registers, what is happening inside registers. So if I open my window of registers, my code is has been debugged and um, compiled. So I just have to open registers. Uh, to open registers. So I hope you can be seeing, you will be able to seeing these registers, processor registers over here. So I'm using R17, R18, R19 in my program. So you will seeing over here these 3 registers. So we are loading R17 with 0. If I move to my second command, so R17 will load with 0, outputting from D port. So I'm loading R18 with 0, R18 to C port, then we are moving on R19, that is 1. So you can see R19 is stored as 11FF. So outputting it from making it output of D port. Then we are moving into a start pro loop, that is we are taking input from R17 pin B, then we are taking input from R18, then we are complementing R17 and R18, then we are next putting this LDIR17 as this, you can see CC, and then jumping to the next to gain this loop, and we will move on until it is complemented completely. So in this way it will work. So if I jump over this loop just to show you the next commands, no, it is not happening. So that was it from this video. Thank you very much for watching.